All right, so we're gonna be solving a two-step equation. Let me start with the first example here. We got 2.5x minus 13 equals to 2. Again, the whole purpose of solving a linear equation is to isolate the variable. We want to know what is the value of x, okay, in order for this side to be equal to the other side. To basically isolate the variable, you need to apply opposite or inverse operations. So, in order to apply opposite operations, we gotta undo in order to do the inverse operations and isolate the variable x, you need to undo the order of operations. And if you guys remember, order of operations is parentheses first, exponents, then goes multiplication, division from left to right, and then addition and subtraction from left to right. We gotta undo that, so we gotta go the other way around. So in this case, we're multiplying 2.5 times x and we are subtracting 13. We're gonna be trying to undo the subtraction before the multiplication. So in order to undo the subtraction, we're subtracting 13, we gotta do the opposite of subtraction, which is addition. So that means that gotta be adding 13 to this side of the equation, and we gotta keep the balance and do the same thing on the other side of the equation. So, negative 13 plus 13, well, they cancel each other. We got 2.5x equals to 15. 2 plus 13 is 15. Now we got a one-step equation. We gotta somehow, isolate the variable x. So 2.5 is multiplying the x. So the opposite of multiplication is division. So we gotta divide both sides of the equation by 2.5. By doing that, 2.5 divided by 2.5, that's a 1. So we got 1x, which is x. And 1.5 divided by 2.5, if you do the calculations, that's going to be equal to a 6. Perfect, right there. All right. Let's try another example. This one, I want you guys to pause the video and try to do it yourselves. See if you're able to get the answer. And again, remember, you're trying to isolate the variable and solve for n. Pause the video and try it. All right, let's see if you got it right. So again, in this case, we're gonna be subtracting 3 to both sides of the equation. So we got negative 2n, 3 minus 3 cancel each other, so 9 minus 3 is gonna be equal to 6. Then we got negative 2n equals to 6, and we gotta do the opposite of multiplication here. We gotta divide both sides by a negative 2. So be careful when you're dividing, okay? A common mistake is students forget about the sign and divide both sides by 2 in this case. But you guys notice it's not a 2, it's a negative 2. So a negative divided by negative is a positive, so that will be 1n, n. Positive divided by a negative is a negative, so we get a negative 3. That should be your answer. If you get it right, you are in the right process of learning, you're solving how to solve a two-step equation. All right, let's go and try to see another type of multi-step equation. This one is, we're going to be using combining like terms. So combining, let me put it like that, like terms to solve an equation. All right, so let's try this example here. We got a negative 12 equals to 9x minus 6x plus 15. Notice in this example, we have several x's there. It's not only one x. So before you do anything, you gotta look at both sides of the equation and see if you can combine like terms. On the left side, there is nothing that you can combine. It's a negative 12, it's a constant. And on the right side, well, we got the x's on the same side of the equation, so that means that we can combine like terms because they're on the same side. So basically 9x minus 6x. Well, we are gonna be subtracting 9 minus 6. We're gonna be subtracting the coefficients here. So that's 3, and we keep the same variable. So 9x minus 6x is gonna be 3x plus 15. Now we got a two-step equation. So next step is subtracting 15 to both sides of the equation. 15 minus 15 will cancel each other. So we got 3x equals negative 12 plus negative 15. So you have the same sign, so you're adding them. So that will be a negative because both numbers are negative. 12 plus 15, that's 27. So that will be a negative 27. I can rewrite it as 3x equals to negative 27. Okay? Now, next step will be basically dividing both sides by a positive 3. 3 divided by 3, that's a 1. So we got 1x. So x, negative divided by a positive 3, negative 27 divided by a positive 3, sorry, is a negative 9. You can always check your answer by plugging the negative 9 where the x is. When you're solving equations, you can plug in always the answer, see if you get a true statement. All right, so I want you guys to try the next one. Okay, that's gonna be negative 2x minus 10x plus 12 equals 80. And let's see if we can put it there so we can see it. Right there. Pause the video, see if you're able to do it. All right, so again, we notice here, let's see if you guys got the right answer. We notice that we can combine these two together because they're alike. Negative 2 and negative 10. If you combine them together, okay, you're gonna get a negative 12, and then we got x, keep the same variable. Plus 12 equals 18. Now, next step, subtracting 12 to both sides of the equation. 12 minus 12, well, they cancel each other, so we got negative 12x. 18 minus 12 is gonna be 6. And this is where you gotta be careful. Common mistake that I see every time is that students will try to divide both sides by 6 because that's the smallest number, right? But no, you're dividing by the number, okay, that is multiplying the x, okay? In this case, you're gonna be dividing both sides by negative 12. Negative 12 divided by negative 12, that's 1, so that's 1x, equals to basically 6 divided by negative 12. That is not equal to negative 2, okay? Guys, you gotta be careful with that, okay? I see it all the time. 6 negative 12 is not equal to negative 12 over 6, okay? That is not equal, okay? Careful, it's not equal to each other. 6 divided by negative 12 is negative 1/2. Because you divide both the numerator and the denominator by 6, you get a negative 1/2. You're simplifying the fraction. Okay, that's your answer. If you want it in decimal, that would be negative 0.5. Simple as that. And don't forget to do the assignments.